So when you have, sometimes we need to simplify expressions, but then we're going to soon transition over to solving equations. Okay. What you want to do is you want to, if there are factorials, okay, you want to try to cancel out the factorials. That's your ultimate goal. I would suggest you expand the greater expression first. For example, n plus 5 factorial is obviously greater than n plus 1 factorial. Right? And n minus 4 factorial is greater than n minus 8, because you're only going minus 4, this is minus 8, so this is actually the greater one. Another important thing here is that you need to make sure that there are certain values for which the expression is invalid, and so these restrictions need to be stated. Simplify the following, state any restrictions. Another thing is there may be multiple restrictions. I usually focus on the largest one is the one that I'm going to pick for my overall restriction. But it's not going to be wrong if you state them all. Okay? So here we go. You have n plus 5, and then you've got n plus 4 factorial. If I ask you to simplify this or combine this, this is really just saying n plus 5 if you think about it. And let's break down this factorial. This will be n plus 4 times, what would be the next one less than n plus 4? It would be n plus 3. And then it would be n plus 2. And that just keeps going. So what does this really look like, though, if you zoom out? Isn't this really n plus 5 factorial then? If you think about it, n plus 5, n plus 4. So that's all. The only trick here is that. N plus 5 factorial. This one isn't, I wouldn't necessarily worry about this one too much, but I would like you to see the pattern there. Restriction. What's my only restriction here is that n has to be greater than or equal to 5. Sorry. One second here. Greater than or equal to, then negative 5, sorry. Negative 5. And this is why. This is just my restriction. I'll show you how I came up with that. You go n plus 5, you take that expression, and you make that equal to 0. Because what we don't want is we never want anything that's followed by a factorial to be negative. We never want that because you can't solve it. So you basically say, well, when is n plus 5? When is this thing? When is that equal to 0? Because that's my limit. I can't go lower than that. And then basically what you do is the n goes over subtracting. It's n is equal to negative 5. So you said that when n is equal to negative 5, this is going to turn into 0. Okay? So what you must say is, no matter what, n has to be greater than or equal to negative 5 for this thing to work. If it's negative 6, if you had negative 6 here, this would be negative 6 plus 5, which is negative 1. Negative 1 factorial cannot be done. Okay? So that's how I do my restrictions. Just follow along as I go. Okay? Over here, let's do the restrictions first. At the top, n is equal to 0, right? Like you make that equal to 0, so that's it. There's no solving necessary. So you just make sure that n is greater than or equal to 0. That's what we want to make sure at the top. That's what happens. Bottom, n minus 2 is equal to 0, right? That expression. So you solve for n basically. Bring the negative 2 over. What happens to negative 2 when it comes over the equal sign? It turns positive. So then you say that at the bottom, n better be greater than or equal to 2. Let's just leave it like that. Like I normally select the largest one. That's the only one you really need. But just give me both and we're all happy. Okay? We're all happy. Now, this is the restriction part. Now let's simplify this. Which one is the largest expression from these two, top or bottom? Which one is the bigger number if you think about it? Okay, maybe you're not sure. Let n be any number you want. Let's say n is 10. Don't copy this down. 10 factorial. What would the bottom be then? 10 minus 2, which is 8 factorial, right? Which one is the bigger one now? The top is. The top is, you've just demonstrated that. Okay? So if you don't see it, try something. Okay? So I'm breaking this one down. It starts like this. N. That's the first one. You always grab whatever is next to the factorial. That's what you start with. The next one is n minus 1. One less than that would be n minus 2. Remember, you're always dropping the original by 1. I will stop there because conveniently I see the n minus 2 in the denominator. That's another way you know you're doing things right or wrong. Let's say you expand at the bottom. How would you start the bottom? N minus 2? What's 1 less than n minus 2? N minus 3? Are you going to cancel out ever at the top? Never. It's not going to happen. So you can't do it. So now this is so satisfying, right? You do that. You end up with n times n minus 1. We're going to distribute that. Okay? We don't want brackets or factorial, so that'd be n squared minus n. That's it. You've simplified that expression. Okay? Can you try the bottom one real quick? Restrictions first. Restrictions first, then you solve. Okay? So you got to do the top, figure out what's not acceptable at the top, figure out what's not acceptable at the bottom, and then you go ahead and solve. I'm solving it up here if you're looking up. N plus 2, right? N plus 1. What would come next? N. Just N, right? So I drop from this. I've decided that the top is bigger than the bottom. And just, again, let's try 10. 10 plus 2 is 12. 10 minus 1 is 9. So the top is bigger, right? So drop it. I will go one further, n minus 1. I would say students miss the n all the time. So please don't ignore it. It is there. That is where you get to, especially when you go with a plus and you drop it. Denominator, it's n minus 1 factorial. And then you cross it out. And you're left with a bunch of n's, right? This takes you back to intro, maybe, the intro course. But don't fear anything. What I would do is pick two brackets at a time, okay? So for example, if I pick these two, I'm gonna go n times n is n squared. N times 1 is just n. Then you move over. 2 times n is 2n. 2 times 1 is 2. And all of this is still being multiplied by that n that's just waiting out there to be included, right? So it's FOIL. Pick the first one, multiply it across. Take the second one, multiply that one across. And now I will pick the n and multiply that one. Oops. You know what? It can be done the way I did it, but I'm going to clean the inside up first. Sorry about that. I'm going to clean this up first. I've got n and 2n, right? So that's really n squared plus 3n plus 2. So I combine like terms, right? These two get combined. Then you distribute. So that would be, what's n squared times n? N cubed, right? 3n times n is 3n squared. 2 times n is just 2n. And there you have a simplified expression. N cubes are not very common, but I think you at least need to know how to do that, okay? All right, let's go on to equations here. I'm going to ask you to do 29 as homework. Page 29. There's 2 there. That's it. Okay? Then let's go to 30. Because of time constraints, I'm not going to go over these steps right now. I'll just show you an example, and then maybe on Friday I'll go back through the steps, because you don't really need to follow them step by step. If you know what we've been doing in this previous section, you should know what to do here. So this is different because you've got an equation. Okay, so this is equation. Solve for n. Okay, that's, you're going to actually have to figure out what is n. What number goes in for n. Okay. So same as before, what's the restriction? Restrictions for the top, n is equal to 0. That's just it. Right? N is, you set it to 0, so that therefore at the top n better be greater than or equal to 0. Bottom is this, so n is equal to 2. N better be greater than or equal to 2 in the denominator, and there you have your restrictions there. Really, you only need to state this one because it will take care of that one. You'll never get down to 0 if you make sure n is greater than or equal to 2. You know what I mean? But state them both, you're not going to be wrong. Now, which one is the bigger expression? Just like before, in this case, n is bigger than n minus 2. So let's break that one down. N times n, what's 1 less than n? N minus 1, right? The next one is n minus 2. Slap a factorial on it, because you're going to cancel it with the n minus 2 factorial in the denominator, and make sure you go is equal to 90. You cancel that out, and just for our work, I'm not going to skip, I'm going to actually write down the clean version of it, what happens when you cancel out. This is very common here that you're going to have to multiply. So this is n squared minus n is equal to 90. And this step, folks, bring everything over to the left-hand side so that there's 0 on the other side. So n squared minus n, what happens to 90 when it comes over this side of the equal sign? It changes signs, so you end up with that. And here is where I'm going to give you options. Do you remember the quadratic formula? You can use the quadratic formula to figure out what n is. I'll just show you here. Write this down if you quadratic formula. If you need a refresher, it's ax squared plus bx plus c is equal to 0, right? Like if you have an equation like that, so if you have a squared term, this is a, the x, right? The power of 1 is b, and this is c. To figure out, we go b, negative b, I actually put that in bracket, plus or minus square root of b squared minus 4 times a times c. All of that. So you first do whatever's at the top, right? Divide it by 2 times a. I will not be using this a whole lot, to be honest. I will show you how to factor. Do you remember factoring? Intro, yes. In grade 11, we didn't do any factoring. Okay, but these are usually very easy to do. So factoring, write this down. Two numbers that multiply, multiply 2c, and they add to b. Two numbers that when you multiply you get c, when you add them you get b. So watch this, it's a guess and check game. You go n is equal to 0. So we're going to write this in terms of two binomials. Okay? What are two numbers that you can think of that multiply and give you negative 90? 9 and 10. 9 and 10. Think easy here. If I were to go 9 and 10, let's say we go 9 here, 10 there. What do I need if I want a negative 90? So one of these has to be negative, correct? Okay, so you got to go negative 9 times 10. That gives me negative 90. This is C, right? So check. But what about negative 9 plus 10? What do I get if I go negative 9 plus 10? I get positive 1. And that is B. Sorry, you can't see that. My bad. So I tried 9 and 10, but I need to make sure one of them is negative. I just went with negative 9 times 10 to give me negative 90. And then keep the signs and add them up. You get 1, which is, oh, sorry. I'm in trouble here, right? Because I get plus 1. What does B have to be? It has to be negative 1. So this doesn't work, okay? So you got to go 9 times 10, negative 10. That'd be negative 90. And 9 minus 10 gives you negative 1. This is B, and this is C. So we're good to go if you go 9, negative 10. So you just got to go plus 9, negative 10 to make that work. It's going to take some practice. So what are my two solutions here? This is the first one. N plus 9 is equal to 0, which means that is n is equal to negative 9. This one does not work. We can't have negative 9 as our answer. The other one is n minus 10 is equal to 0. The 10 comes over is equal to 10. This is the one that works. So the only way this expression works, this equation works, is if n is equal to 10. Alternatively, if you plugged in A, B, and C into the quadratic formula, you would have arrived to the same conclusion. Okay? All right. Let me see here. I'm just going to ask you to do certain ones here. Let's try just page 33. Page 33, do the equations there. And the answers are at the bottom of 33. If you look, they are at the bottom of 33. Okay. One more thing before you, I know you're eager to get started. Don't forget about, like, flip through your booklets for the quiz tomorrow. Like, for example, remember how many pizzas can you order, right? You've got 5 crusts, certain toppings, all of that stuff. I gave back that AC. Use the ACs. Remember how many roads there are to go from town A to town B and B to C? Remember that one? And don't forget about the number of roads on a grid. Do you remember that one? I'm talking about this kind of stuff. Don't forget about that. Like there's some that are going to be classic that you can just expect. Roads, pathways, words with identical letters, all of that kind of stuff you can just expect. Passwords, and so forth. All right?